let's go ahead and define the real number system. Okay? The first place I'd like to start is with the natural numbers. The natural numbers are oftentimes called the counting numbers. Okay? So the definition of the natural numbers is the set 1, 2, 3, 4, 5, 6, etc., etc., etc. Okay? So these are our counting numbers or the natural numbers. They're just the positive integers starting with 1. Okay? Well, the whole numbers, that's just going to be the counting numbers, but we're going to include one more element, the element 0. Okay? So if we just add the element 0 to our natural numbers, we get what's known as the whole numbers. Okay? So 0, 1, 2, 3, 4, 5, etc. Okay? Now if we add the negative numbers, the negative integers, we get the set called the integers. Notice our set 0, 1, 2, 3, 4, etc., etc. We can also go to the left, 0, negative 1, negative 2, negative 3, negative 4, negative 5, etc. So the set of all positive and negative integers is called the integers. All right. So those are the numbers that we've been accustomed to working with. Okay. There's two more sets we have to talk about. The first one is called the rational numbers. And let's take a look at the definition of a rational number. A rational number is a number that can be written as the quotient of two integers. Or if we want to put this in our set builder notation, it's the set of all p over q, okay, such that p and q are integers and q is not equal to 0. Okay, very important that our denominator here cannot be a 0. Let's look at some examples. 5 over 17. That's the quotient of two integers, so that is, by definition, a rational number. Okay. Negative 99 over 43. That's an integer over an integer, therefore that is a rational number. Note, 5 over 0 is not a rational number. 5 over 0, we can never have 0 in the denominator here, so the number 5 over 0 is actually what we say is undefined. Okay? Anytime we take a number divided by 0, it's an undefined value. Okay? Notice 6 over 1 is a rational number. It's an integer over an integer. And notice if we wanted to reduce 6 over 1, we get 6. Okay? Negative 19 over 1 is a rational number. We could reduce that to just get negative 19. Okay? So what does that really tell us? Well, it tells us that every integer is also a rational number. If ever we take an integer value, say 5, we know that that is also a rational number because we can write it as a fraction of integers. Okay? All right, there's some other portions of the rational numbers that we have to talk about. Every terminating decimal or every repeating decimal is a rational number. Let's take a look at a terminating decimal. Example, 0.17. There's a decimal value and it terminates. The decimal ends at 7. Okay? That can be written as 17 over 100 if we wanted to write that as a fraction of two integers. So for every terminating decimal, you can always find the fraction, okay, or the rational number that represents that. So every terminating decimal is a rational number. Every repeating decimal is a rational number. For example, 0.333 ... forever. If you remember from way back, you could also represent this as the number 0.3 with the bar over the 3, which represents that this 3 will repeat forever. That is also a rational number. And if you happen to know what that ratio of fractions was, 1/3. Okay. Another example might be 0.127, 127, 127. Notice that we get this repeating pattern. Okay. By definition, that is a rational number. So Any fraction is rational, any terminating decimal is rational, and any repeating decimal is rational. All right, the last one. Well, we could get numbers that are decimals that do not repeat or do not terminate. These are called irrational numbers. Example, 3.1415927 ... Notice there is no pattern here. These dots mean that it's going to go on forever in some random order. Okay? So if we have a decimal that does not repeat, okay, just has a random order, that's known as an irrational number. A lot of square roots that do not reduce are also examples of irrational numbers. Square root of 2, square root of 3, etc. Okay? So that's our whole number system. And let's take a look at a set, and we'll try to figure out what portion of our number system each one of these numbers is in. So here's a set, contains 1, 2, 3, 4, 5, 6, 7, 8 elements, and let's determine which are natural numbers, which are whole numbers, which are integers, which are rational, and which are irrational. All right, well, let's just take a look at, let's just start with the natural numbers. Remember the definition of a natural number, okay? Those are our counting numbers that started at 1. So that's not a natural number. No, no, no. That's not a natural number, right? The natural number started with 1. Negative numbers are not natural. No. So the only natural number here is the element 53. Okay? Remember what the whole numbers were. They were our natural numbers, including the element 0. So our whole numbers from our set here are 0 and 53. Okay? Now the integers, remember, are our whole numbers that include the negative whole numbers. So our integers, negative 5 is an integer, 0 is an integer. Notice the square root of 25 actually reduces to 5. So that's actually an integer, right? The square root of 25 is actually 5, and 5 times negative is negative 5. So this is actually an integer. That's not an integer. 53 is certainly an integer. All right. The rational numbers. Those are our fractions, okay? The ratio of integer over integer, and all of our repeating decimals and terminating decimals. Negative 5 is rational, remember, because I can write that as negative 5 over 1. So negative 5 is a rational number. No. 1, 2, 3, 1, 2, 3. Notice it's going to repeat. So that is rational. There's a ratio of an integer over an integer. That is rational. Here's an integer. That's rational. Same here. There's another integer. That's rational. That's not rational. We can't have 0 in the denominator. But certainly another integer is a rational number. Okay. And the irrational ones, well, square root of 7 is irrational. And that's it. Now, notice the only element in our set that we did not account for is this guy here. And remember, by definition, 9 over 0 is undefined. 9 over 0 is not a real number. Okay. So, you might want to review this again. Look at the definitions of the natural numbers, the whole numbers, the integers, the rational numbers, and the irrational numbers, because you will need to know how to distinguish one element from the next one. Okay?